Hello everyone, I hope you're having a wonderful day. My name is Muhammad Bazakuan bin Zaman, number metric 085518. Today I am going to present and give a short explanation about Chapter 3 of Computer Architecture. For those who may not know, Chapter 3 discusses the characteristics of the memory system and memory hierarchy. The memory hierarchy consists of each several levels, which are register, cache, main memory, and secondary storage. Each level have different characteristics in terms of speed, size, cost, and access time. Let us begin with the register. Registers are the fastest memory in a computer system. They are also the smallest in size and the most expensive memory per bit. Registers are located inside the CPU and they are used to store data, instructions, addresses that are currently being processed by the processor. Because they are inside the CPU, registers can be accessed extremely quickly, which help improve overall system performance. Next, we have cache memory. Cache memory is divided into three levels: L1, L2, and L3. L1 is the fastest and smallest, while L3 scale is larger but slightly slower compared to L1 and L2. Cache memory is still very fast and more expensive than RAM, but it is cheaper than register. The main purpose of cache memory is to reduce the time needed to access data from the main memory by storing frequently used data and instructions. After that, we move on to main memory, which is also known as RAM, random access memory. RAM is slower than cache and register, but it has a much larger capacity and is less expensive. RAM temporarily stores programs and data that are currently being used by the computer. However, RAM is volatile, which means all the data stored in it will be lost when the computer is turned off. And finally, we have secondary storage such as hard disk drive and solid state drive. Secondary storage has the largest capacity and is the slowest memory compared to other memory types. However, it is also the cheapest per bit. Unlike RAM, secondary storage is non-volatile, meaning data is permanently stored even when the power is turned off. It is mainly used to store operating system, software application, and user files. In conclusion, register and cache memory are very fast but cost more per bit, while RAM and secondary storage are cheaper and have larger capacity. But they have slower access time. This memory hierarchy helps balance performance, cost, and storage capacity in a computer system. Alright, that's all for chapter 3. We will continue with our chapter 7.
Hello guys, my name is Muhammad Elzi Faisal Biasa and my matrix number is 085706, and I'm going to talk about chapter 7, parallel processor. In this chapter, I'm going to explain the difference of multiprogramming and multiprocessing. First of all, multiprogramming only uses one CPU and multiple programs are loaded into main memory. Therefore, there is no simultaneous execution. So secondly, I would like to explain briefly about multiprocessing. Multiprocessing is obviously different from multiprogramming, so it uses two or more CPU to execute multiple programs at a time. It means there is true parallel execution. So now I'm going to show you a table that is easier to understand about multiprogramming versus multiprocessing. So that's all from us. Goodbye.